Since they tell us there's infinite number of solutions, we know these are the same equation. So all I have to do to solve a problem like this is take everything in front of my x, everything in front of my y, and my constant from one equation and put it in a bracket. And in the other bracket, I just need to put the same x, what's in front of my x, times the scale factor, what's in front of my y times the scale factor, and what's my 5/2 here is my constant, also times that scale factor. We're looking for the value of k here. K is 12.25. If you still struggle when you see constants on the SAT, then this video is for you. This new Desmos trick can't be applied to every constant problem, but it can be applied to very specific ones, and when you know how to do it, you never have to solve those problems again. The types of problems we want to be looking for are systems of equations with one or many constants. If that question is talking about no solution or infinite number of solutions, then you can always apply this Desmos trick. Instead of wasting time with sliders or long-form algebra, we can write one line on Desmos that solves it for us. Looking back at the problem I just solved, we can see that all I did is take my x values from both equations and set them equal to each other, my y values from both equations and set them equal to each other, and my constants from both equations and I set them equal to each other. Everything on one equation is going to be multiplied by some scale factor. We can call it n. We can put any constant here because these are the same equation, but one has been altered by some scale factor. So if we forget that, our answer is going to change. But with this one line of code, we can solve a no solution or an infinite number of solution equation using this instead of trying to solve it another longer way. If the scale factor doesn't make sense yet, that's fine. Let's look at this next problem that'll help you understand why we have to do that. Okay, this problem also talks about infinite number of solutions. Like in the last problem, that means these equations are the same. So, without doing any math, without trying to plug this into Desmos, just take a look at this problem and see if you can figure out what k is. If your guess is 2, you're correct. So how do we intuitively know this is k? Well, we see from the other parts of the problem that the x got multiplied by 2 to get 2x, the 3 got multiplied by 2 to get 6. So 1y, which got multiplied by 2, would also give us k, which is then 2. Looking back at what a scale factor then is, in this case, the second equation is the first equation multiplied by 2, the scale factor there. Let's try and regress this just so you can see the process one more time. So just like the last problem, I'm going to put the number that's in front of my x, the number that's in front of my y, in this case k, and then my constant 6. And then on the other equation, I'm going to do the exact same thing. So the number in front of my x is just a 1, but we're going to put the scale factor. In front of the y is also just a 1 times the scale factor. And then the last number here is a 3 times scale factor n. We see here that k is 2, and that's what we already figured out. So the reason we need this scale factor is because if we take this out, we still know that these two are the same equation, but right now we're saying 2 is equal to 1, 6 is equal to 3, and that's not necessarily true. We're saying these two equations are the same if this equation on the right was multiplied by 2. It would be the same as the other equation. So we always need that scale factor, but it actually doesn't even matter what side it's on. So if we took it out and put it on this side, do we think we're going to get the same answer for k? It says that k here is 2. If that kind of makes sense for you, here's one more problem you can try that's very similar. I'll put the answer to that one in the description. Now that we can solve any systems of equations problem with constants with infinite solutions, let's see if we can do the same thing for no solution problems. So before trying to solve this problem, what do we know about no solution? Well, if you said the lines never touch, you're correct. If you said they're parallel, you're also correct. Why is this important? Well, if two lines are parallel, they have the same slope and different y-intercepts. So for example, if I had y equals 3x plus 5 and y equals 3x plus 20, we have the same slope and different y-intercepts. So this would be an example of no solutions. So when I'm making my regression, everything is exactly the same as the last problem, except our y-intercepts shouldn't be the same, so the constants don't even have to be included in my regression. Only grab the things in front of the x's and the y's and do the same steps as before. Just like infinite number of solutions, we're going to start with our brackets. So 3/10, because that's our x value. Our y value, we're going to need to combine here. So if I add 5/8 on both sides, I'm going to end up with 10/8 as my y value. So that's it for my first bracket. On the second bracket, our x term is 7/10, so that can be that, multiplied by our scale factor, which we can't forget. And then our y terms, since we brought all the y's to the left side of the equation, then we should do the same here, which makes this negative k times n. So what is the value of k here? It's negative 2.91667. Let's stop right here before we go on. This system of equation only has one constant. Some students think with one constant you can just use a slider. This is the prime example of when a slider would never get you the right answer. It is true you could solve this with algebra, but it would take much longer. If that problem made sense to you, here's another no solution problem that you can try on your own. I'll put the answer to that in the description as well. Remember, this Desmos trick should be used specifically for systems problems with constants regarding infinite or no solutions. If they ask about one solution, there's a different way to regress it, but I will talk about that in a different video. Let me know in the comments what you want me to cover next.